So we will see the dynamic problem, and in this dynamic problem we will find the longest path in the weighted grid. So our target is to find the longest path and with the maximum number of score. So to find the maximum number of path, the output will be the weighted grid with two distinguished vertices. One is the source and the other vertices is the sink. We have already seen starting point is the source and the end point is the sink. And what we will get is as the input is the longest path in G with the source to sink. So we can see here, we have already discussed that tourists can move only in two directions, either in the south or in the east directions. And they cannot move in the west or north, and these positions in the north and west, they are unusable. So any grid position south or east of the sink are unusable. And sink could be any point because this is the source point, and with reference to this one it could be a sink also. So we cannot use the, for example, if it is the sink point, then we cannot use this point and this point. We cannot use points in the north and west directions. So we assume that the source vertex is 0 and 0, because whenever tourists will start from the source, the value will be 0 and 0. But the sink value will be n and m. That defines the southeasternmost corner of the grid. So this is the sink and it denotes as n m value. So we will see the difference between the brute force and the greedy algorithm if we try to find the Manhattan tourist problem. So in the brute force approach, to find the longest path, and this is not the optimum to the medium to the large grid, because we know that in the brute force algorithm it will recompute it again and again, and it will take a very long time. So in contrast, the use of greedy strategy, we will choose between the two possible directions by comparing them and selecting one with large increase for one step. You will see practically in the next slide. So these could be, greedy algorithm could be very good at the beginning, but it may lead to a very few attractions area. So no greedy algorithm could be the best possible optimum solution of this Manhattan tourist problem. So we can see here, so we assume that this is the grid and there are different possibilities that a tourist has started from the source and end up in the sink. So we will calculate all the values that are written on the vertices. So we can see that this is the 14, and if the tourist will adopt this path, it end up at the sink with 13 score, and if it use this path, it end up at the 17, and so on. So we can calculate all the possibilities and we can calculate the score also, and we can find the maximum score in all of the possibilities. So the maximum score in all of these possibilities by using the brute force algorithm is 20. So we can say that this is the optimum solution of this problem. But we can see here we have to calculate the maximum, rather all possibilities that are possible in this grid. So it will take a lot of time and lot of work is required. So the other thing is we can rather get the optimum condition, but after doing a lot of work. So on the other hand, we can see that this is the greedy algorithm approach. The tourist just started from the source point and it moves in this direction, then in this direction, and then it takes 17 score by using this path. So if we compare this one with this one, we can see here by just adding the one step further, it started from this one, and we just add, this is actually 2, we just add another step ahead of this one. So in this greedy algorithm approach, we just add one more step and then we calculate the total after reaching at the sink. So by comparing this 17 with 15, we can say this is the best path that the tourist has followed, but we cannot say that it is the optimum approach because we are just adding one step in the previous path. So we cannot say that this is the optimum score we have obtained. Rather, we can there is no optimum solution of the Manhattan tourist problem in the greedy algorithm. So we cannot use either brute force or greedy algorithm to calculate the best path in this problem. So instead of using the brute or the greedy algorithm, by solving the Manhattan tourist problem directly, that is finding the longest path from source, we have seen 0, 0, from the starting point to the end point sink NM. We solve the more general problem. Find the longest path from source to an arbitrary vertex ij. We will see later, with 0 is less than or equal to I and I is less than or equal to N, and similarly 0 is less than or equal to J and J is less than or equal to M. So then we will denote the length of such path as Sij, noticing that the SNM is the weight of the path that represent the solution to the Manhattan problem. So we will see later that these two values we will calculate and find the longest path with the maximum weight.